and go to our presentation. And so there's a slide that talks about the overloaded function calls. Most cases are intuitive and unambiguous. Some ambiguities can be resolved by the compiler by looking at the parameter lists of functions. If not, it's an error and it needs to be resolved by the programmer. So the resolution attempts by the compiler is as this: exact match, promotion, and then conversion. Okay, what it all means is that, I mean, again, we'll see. Let's try to talk about this. For example, this is an exact match, right? We have reset GPA with exactly this signature, no parameter, so there's no question what function is intended to be invoked with this name. The next case, with 2.0, this is a double. Then it's again an exact match with this one, and this is an error. So let me get rid of this one for now, not to confuse our compiler here. So it's but if I used an integer here, not 2.0 but integer 2. Let's see if this compiles. Let's see if the compiler will be able to still work with this. By the way, I have them defined, so perfect. So let's try to build this. So this time the compiler never complained, so it worked. So what happens is that this is the second case. Integer 2 gets promoted to double 2. It's almost like using promotion to double. It's like a double is constructed from an integer, and now so someone's trying to give it an integer, but the compiler internally promotes it to double because it finds double, and in its set of rules of promotions, it's okay for the compiler to attempt to promote integer to double. Okay, so it's trying to do that. So that's the example of the promotion. And finally, there may be instances of conversion. So I don't know if we can look at some of the examples. So let's look at some of these examples here. Other set of examples resolving overloaded function calls, right? So we have three functions named print. Notice that I never even defined these functions because they could be defined elsewhere. They could be defined in a different file. Who cares what print does? But these are the set of signatures that we use to resolve print calls. So first attempt. So here's a function. We make a call. Exact match with this guy, right? So character literal matches character input parameters here. We have a definite call. Exact match with integer right here, right? So we have an integer, integer parameter. This print will be called. Then we create a short integer, right? A short integer. Short integer, of course, will be like half the size of a regular integer, perhaps 16-bit integer. And then we use, well, I guess I have a typo here to, this should say XX and not X. All right. So X is promoted to an integer. So short integer, 16-bit, maybe gets promoted to a 32-bit integer, and that's okay. That's the promotion, right? The next thing is that 3.4 is a double, and we don't have anything that matches double because there is no promotion of double to an integer. Yes, it can be done. And it's done, for example, when you assign double to an integer, kind of like brute force. So it just drops the fractional part of a double precision floating number and uses the whole part. But in case of a function overloading resolution process, compiler says no. I am not going to do this. Is too dangerous. I'm not going to work with the double here, which clearly is the double value. You're going to have to make adjustments here. So you're going to have to do something like this, right? In case of this, well, maybe what you could do in real life, and I'll just type it someplace. So what you could do is you could explicitly convert your double to int. That's okay, right? well, I don't have print defined, but this double is forcefully converted to int simply by dropping this fractional point, and we just get an A3, right? Even if this was like 9, there is no rounding. The fraction is dropped completely, and we go straight to this part, and that's what becomes an integer. So this is a potential workaround. Okay, next, print message OK, or print using the string OK. This is an exact match with character pointer, because if you recall from CIS 155, a literal string returns back a pointer to the first character, and that's exactly what would be good to make this call, right? str here parameter is a pointer to a character. You've got your characters here, so what's going to be passed to this version of the function is the address of this first character, capitalized O. All right. And finally, there is, well, I guess this is for the future, but this is a bit of a dangerous, potentially dangerous situation where you may be thinking, if I'm using a null macro, which is used with pointers a lot to initialize pointers to like 0, it's in fact defined as 0. You may be thinking that, oh, because I have a pointer version here, then I will be calling this. In C++, null is simply defined as 0, and this is where it's going to go. So let's try this. So let's try this. Right, those 3 functions, like real quick, quick and dirty. Like define these 3 functions that actually do nothing. Right, just bring them into the scope, and then say print. For example, oh, we can keep this print in scope, and we can say print OK, and we can also say print null, right? Just to see where is it all going. Okay, so first save it and build. Okay, so it builds. That means that compiler found a way to resolve all these calls to these 3 functions. Perhaps, to make it easier to observe, let me move it up. So now we can have all 3 in view, right? And also let me have it on like this, because it's easier to debug and view this in debugger. So save. One useful feature is to debug Windows breakpoints. You can actually use this window to delete your breakpoints, because once I set the breakpoints, I use them, I no longer need them, so you can get rid of them. So press F9.